Richard landed in SFO at 4, and he's leaving at midnight. So give him an extra applause for that.
Hello everyone. Welcome. I am speaking today on the safety and ethics for advanced autonomous artificial intelligences. So, first I'll give a broad rundown of what it is we're going to be talking today, which is this, exactly. A little bit meta. A little bit about what the Future of Life Institute is. Dispelling some myths about what some of the concerns are out there and how to think about the future in the first place. Looking at some of the opportunities and challenges, just in very broad strokes, of AI. And looking at the short, medium, and long-term societal issues that may come about from AI. Plus, we have a nice technical overview of what we might call misalignment and alignment. So alignment basically means getting AIs to do what it is that we want them to do. Misalignment, it's doing other stuff. And it turns out there's some very interesting, meaty technical issues with that. That's not simply bugs. Or rather, there are new classes of bugs that can come about in advanced AI. And then we'll consider the fact that from this point forward in human history, we're going to be having, or I should say, from maybe, who knows, 50 years from now or 10 years from now, or whenever we get what might be considered really advanced AI, from that point forward, assuming that we don't all die from something else or that we don't have something knocking us back to the Stone Age, then we will have advanced AI for the rest of human history. And that will change the way that history unfolds quite significantly. So, to get started. So the Future of Life Institute is a group of scientists who work to make emerging technologies safer and more beneficial for mankind. Max Tegmark is the original founder, got these other 4 founders together. He is a cosmologist who thinks about the very long-term potential of mankind. And I'll get to that a little bit later toward the end of the talk. On the AI side of the house, we have significant advisors, including Stuart Russell, who wrote probably the most famous textbook on AI, and Francesco Rossi, who has been quite prolific in both AI and AI ethics, as well as Nick Bostrom, the author of Superintelligence, and Elon Musk, who I hear does a little bit with AI next door. So, just a means of brief overview. So we currently fund about 37 academic teams around the world working on various types of technical remediations for some of the issues that we'll be talking about soon. And toward the end, I'll get to what we plan for a second grant round. But these are some of the better headlines about things that we've been involved in. I would like to highlight that probably the vast majority of things you've read from the vast majority of media outlets have probably been quite skewed or twisted on the concerns or the presentation of the concerns coming from my circles. Oftentimes, it's a game of telephone where the journalists are not fully understanding the issues, and then they're copying from other journalists who kind of have already twisted some things, and so there's a significant attenuation that's going on. So to dispel some of the myths, so saying that either superintelligence, and let me define superintelligence, it's basically a level of artificial intelligence that is extremely general and is extremely powerful, both in its computational abilities as well as its actual ability to affect the world, and can be thought of almost as a new force of nature. So Saying that it's inevitable by 2100 or that it's impossible by that same year are both essentially myths, because we really don't know when this would happen. AI experts disagree on this. The median of their projections is around 2045. That has actually, I think now it's around 2042 or something. It's moved up recently. But it does vary quite a bit. One might think that only Luddites worry about AI and the safety aspects or the ethical aspects of it. But in fact, many top AI researchers and professors and folks in industry are actually pretty concerned as well. There's been a lot of media or I don't know, movies around AI turning quote unquote evil, or it getting consciousness or self-consciousness. And those are not the actual worries about AI in the long term. Whether it has this sort of metacognition that, you know, is able to lend possibly some properties of you know, self-reference or self-consciousness is really beside the point. And it's not just that it's going to spontaneously become evil. The real worry is that it's going to be very, very competent, and it's going to do what we tell it, but that we really don't know what to tell it exactly. Basically, the goals that we've stated are misaligned with our intended real goals, or that we don't actually know what goals we want to give it in the first place. And this may seem trivial, but it turns out it's really not. And it's not that robots are the concern. Really, I mean, robots are shells. It's really the intelligence, the misaligned intelligence, that could just live on an AWS instance somewhere. So another myth is that AI can't actually control us, that it's not going to be able to take over things. But we control tigers that are more powerful than us physically by putting them in cages. We're smarter than them. So if something is smarter than us, it may very well figure out how to control us. And there's this concept of you know, since a machine is just a machine, it can't actually have a will, it can't actually have goals. But when you're playing against, you know, AlphaGo, you know, its goal is to win at the game of Go. I mean, that's effectively what it is trying to do. A heat-seeking missile has a goal of hitting the heat target effectively. So, in effect, these systems have goals. Maybe that's a slight metaphor. There's lots of metaphors in AI. I mean, the whole field is built on metaphors, and pretty much entirely. So I think we need to appreciate that. Lastly, when people talk about these issues and the fact that there is potentially reason for concern, that doesn't mean that these systems are imminent today, or that we say that things are at this level today. It means that we should be cognizant of these issues today, because working on remediations for them, working on creating the fields that will produce the proper type of research to deal with these sorts of issues could in itself take decades. And so even if these things are decades away, we should get started now. Okay, so how do we think about the future? So it's one thing to just come up with a story in one's head and prognosticate and come up with fantasies. That sort of approach can be good for getting the juices going, the creative juices. But really, when one wants to kind of plot out what are the possibilities and with what probabilities and how things might interact, there's more methodology that comes into play. And drawing the boundaries of what's possible is quite important. So there are logical constraints on what's possible, and there are physical constraints on what's possible. So In terms of the physical constraints on the power of computation, I think there's been a calculation to the effect that we are about 23 orders of magnitude away from the density of computations per square millimeter that we can be. Something, I may be mistaken about that, but something around 23. So things can get much, much more powerful than they are today. When it comes to logical constraints, that's essentially looking at things like information theory, looking at things like foundations of rational agency, looking at the fundamentals of what knowledge or semantics are, or how information can propagate. The building blocks that we'll use when thinking about the future are oftentimes today's theories, today's technologies, today's techniques, but looking at plausible evolutions of them and what sorts of what sorts of directions they might be iterated toward, and being able to have some kind of confidence and probabilities around characterizing those. Those will, of course, interact. There will be dependencies, there will be synergies, there will be dissonances between them. And synergies can be a very powerful accelerator when we're talking about these types of technologies. Dependencies are quite good for picturing how things will need to stagger in time. So when we actually communicate about these issues, it's convenient to talk about kind of shorter term, intermediate term, longer term. When we talk about shorter term, that's anywhere from essentially today to 2 years from now to maybe 5 or 10 years from now. Intermediate term is probably around 7 to 35 years from now, potentially. Longer term is essentially maybe 20 years from now to the end of the universe. We do expect some big things to happen this century. But it's important to realize that, this is not just history is going to play out one way or another. We are extremely active participants in how it's going to be playing out. And choosing to work on one thing or a different thing is actually a pretty important decision that all of you actually have. These are differential technological developments that are going to happen. Things will happen at different points in time. And sometimes it matters what happens before what. It's not inevitable that the given type of thing you see a job offer for is actually going to happen. Maybe you're the best at it, maybe you have certain insights, and if you don't take that job, then it's just not actually going to happen very well, and the project will be canceled. Maybe that's something you actually want sometimes. Opportunities and challenges ahead for AI. So I started with some negative comments, but AI is really and should really be a really great thing. It can bring some really transformative benefits to mankind. There's no reason that within, on a decade's time scale, it won't be essentially automated scientists curing diseases, or home robots assisting the elderly, or simply freeing people from doing tedious and annoying, dangerous jobs. There's a lot that intelligence can be leveraged for. And it would be great if we simply get it right and are able to enjoy those benefits. But there are also totally novel pitfalls that we need to address before they become too big to address. So I'm sure everybody here has seen 2001, or if you didn't, then obviously you should. Hal, I really can't do that, he says, or that's not the exact quote, but you get the gist. Is it really doing what we as designers or owners, users want the system to be doing? And how sensitive is the system to unwanted side effects of its actions that it's choosing. How much context does it have around those sorts of things? And what happens when the environment it's aware of includes itself? It can start modeling itself. It can start trying to figure out interventions on edits to itself. And that can get to some very weird dynamics. As the concept of AI and agents and autonomous systems becomes more broad over the years, the what we might call agentic behavior, being able to sense and act in some environment, optimizing for some implicit or explicit goal, growing the breadth of the action space that it's able to operate in, action space being the types of things it can do in its environment, the types of actions it can take. And the optimization power, the raw computational ability to delineate and explore and model options and evolutions of consequences before actually taking the action that would get to them. So we get to some qualitatively new challenges. And I should say that also when looking at this broadening agency, the generality of these systems is indeed growing every year. So being able to have multimodal representations of things, being able to have transfer learning, zero-shot learning, or one-shot learning more and more, being able to have systems that are able to use the same infrastructure, the same potentially neural network for multiple different behaviors, kind of doing some potential meta-management of that neural network for learning some skills and sort of managing that set of skills that it has. These are all things that are actively being done in labs these days. And every year it becomes broader and broader in what a single system can do. So in the short term, when we look at things like self-driving cars, or potentially in a couple of years, home robots, we'll need to consider what sorts of ethics will be embedded in these systems, and the preferences, and how these two are related, and what sorts of layering there might be for potentially when it comes to things like self-driving cars that may go cross-border, let's say in Europe or US to Canada or something. We maybe there'll be some basics that the UN might want to put in place for human rights or things like that. And then maybe country level, maybe particular companies, manufacturers will want their own rules. Maybe they'll give the owner some layer of preferences they can add on. Maybe then the operator can layer on some additional preferences. It could potentially be some sort of pyramid of just how wide those preferences can range in terms of tuning those knobs. Like, it's always good to give somebody the ability to tune some knobs so they feel some agency, but exactly how broad you can tune those knobs can be set at a layer below in the stack. So we also get to liability issues. So if that home robot is going out and picking up some milk from the grocery store, and it accidentally trips somebody, as it's running, who's liable there? It's kind of a new issue. I mean, it's a little bit similar to, leaving your car at the top of a hill in neutral, and then it happens to roll down a hill and, hit somebody or not. So potentially one can make an argument that no new laws are needed, but as we get to more complex scenarios, it's likely that there will be such needs. Governments like the European Parliament have actually jumped on trying to do something about this and have actually created a sort of construct similar to a corporation that would be able to wrap around agents like this, which is not necessarily the best issue, and it's probably that Europe did this a little bit prematurely. But it's a very interesting set of issues that will be discussed, I'm sure, in all countries and transnationally as well. Probably the most serious, very short-term issue is autonomous weapons, or I should say lethal, kinetic, offensive autonomous weapons. So not talking about today's drones, which are generally flown by wire, flown essentially as by remote control, and not talking about cyber weapons, which sort of natively live in cyberspace, so it kind of makes sense that they would be autonomous. But things where they are kinetic kill machines, where they autonomously choose their targets and then engage them. So I know this sounds extremely like Terminator, and generally FLI tries to stay away from Terminator-like imagery, but I mean, this is actual R&D and products and policies that are being supported and generated by over a dozen countries now, where they actually want these things. And we think that that is not a good thing for the world. So I'll get a little bit into that a little bit later on. So medium term, there are many unemployment-related issues. So historically, new technologies have both created jobs and destroyed jobs. And it's likely that AI will be doing the same thing. But it's a matter of exactly how quickly will jobs be created and how quickly will they be destroyed, and in what industries, and with how much effort and how much friction will people who are losing jobs be able to take the new jobs, and will those new jobs be able to actually support them nearly as well. And then as AI does more and more for us, will we lose our capabilities of doing some very important things, totally lose some competencies that we've had. Long-term AI and the value alignment issues are really these issues of safety that can become existential, where if these systems are extremely powerful in capability and extremely powerful, like economically and physically and politically, then it's plausible that they can be operating for years without issue, and then because of some new type of bug, essentially, that in theory we could have actually predicted would have happened, something catastrophic can happen. So hopefully more often this will simply, the same sort of dynamic, the same sorts of emergent properties will actually surprise us with cool new solutions to things. And it's likely that that's actually what will happen the vast majority of the time. But it's important to understand exactly how these, what I'm calling now emergent properties, will emerge and why, and be able to have some techniques and algorithms for making these mechanisms more robust. So I'll get into a long technical, I'm sorry, yes?
About emergent properties, one idea, this is a comment, is if you had a home cleaning robot and it went from reactive cleaning messes to proactive, you need to add some other constraints so it doesn't chase out the cat proactively to stop making messes in the house. So
Good point, good
just
point.
as an example of something you wouldn't need if you're being reactive, but as you emerge to being proactive and forecasting what's causing the mess.
Fair enough. Okay. Okay.
Well, then email the owner.
Or maybe it takes you out of the house.
Yeah, that would be scary.
Okay. So going forward, I'd like to save questions and comments for the end. So if you can make sure you remember them, repeat them to yourself a couple of times to do that. So you'll be able to ask them at the end. So long term, we get to also, in looking out, decades and centuries and millennia and billions of years, what do we want to be as a society, as a species, as a planet, or as existence? I mean, in a way we can choose now, but not for too much longer. It's sort of a window that is open, and we are at a very special point in history, in this century, and most people don't appreciate that. But hopefully later in the presentation you will. So back to lethal autonomous weapons briefly. So some of the issues that we see with them is that hurdles for starting things like wars and skirmishes, assassinations, political repression, things like automatically targeting people by political party based on their Facebook profiles and killing them based on that. A single person could, tell a fleet of drones or potentially micro drones to go do that. And that's kind of an issue. Especially as the systems become more powerful and smarter and faster and smaller. It becomes very asymmetric, that it's much easier to do offense than defense when these sorts of systems exist. And really the types of concerns that we have are not with what's in the picture here of a contemporary, autonomous weapon under R&D, but really when these things become, much smaller and smarter in the years to follow. We think that it would be pretty geopolitically destabilizing because the large countries with the large armies will not really have a need for those armies anymore. And they'll be on pretty much an equal playing field with countries that can simply manufacture these essentially synthetic fighters, whichever form that they take. And wars would be started much more easily and escalated much more easily. So there's actually an open letter by 100 different AI and robotics companies calling for the UN to ban what's called sometimes killer robots. So I invite you to Google that. So another issue, AI-induced unemployment. So I think a lot of people have a lot of fears around this, and these fears are founded. Different jobs will be replaced at different speeds. It's likely that in the limit there is no job that is safe, but it's also very likely that as people living today, one can pick a job that is much safer for much longer. And there have been lots of different analyses of these different time frames and different types of roles. Oxford had a study a few years ago, McKinsey, PwC. This graph on the right has been making the rounds a lot. It's from an organization called AI Impacts that has surveyed, I forget the exact number, but hundreds or thousands of AI researchers to see when they think various types of tasks will be possible to automate. So you'll note that both truck driver and retail salesperson are both less than 15 years away in this graph. So these are people who actually need to make this happen, who say, yes, I think I can actually do this within 15 years, or we can do this within 15 years. And I'm sure the companies next door actually have, autonomous truck drivers in testing already. So getting to, and actually, let me briefly talk about possible remediations for this. So One that has been talked about a lot is universal basic income. Variants of this include things like a negative income tax. In a way, it's getting a little bit to the Star Trek economy of like just the concept of credits, where like money becomes much less important. Really, when material goods and services are very easy to manufacture or create or generate, then one, has to consider that maybe things should be restructured. Maybe we should look at what we want to be as a society. So, because it would kind of change the nature of what it is that we spend our days doing. Yeah. There are many technical considerations to this alignment of powerful AI systems. So there's ensuring that these systems share our values, making sure that they're not oblivious of context or environment or of side effects of their actions. There's making sure that these systems are not simply not simply gaming their reward functions or hacking their reward functions in a way that lead to essentially going in circles of what seems to provide reward, but is in reality not what was originally intended. And there's looking at what's called instrumental incentives. So getting more resources or getting more compute power or being able to just learn more and more constantly. All these things are useful for almost any goal. And so these will essentially be emergent subgoals, and I'll get to that in a bit. So the question becomes how much greed, how much desire for just instrumental utility is good to have in these sorts of systems. And how can we have oversight of these systems in a way that can scale? This is a tough question, but we'll get to some possible answers. Fundamentally, and this may be surprising to some people, or maybe not, the theoretical foundations of what an autonomous agent is and should be, or how it's defined, is actually quite thin. Decision theory is not a complete science, and the study of the foundations of agency is really in its infancy as well. So being able to formalize those much better will be very important for being able to formalize ways that we can make robust systems. And then there's actually implementing systems, the verification aspect. So verification is going from specification to implementation and seeing how we can make sure that that implementation actually meets that specification. And here, when we say security, this is not standard IT security, although that is obviously very important too. There are new types of security issues that come up with AI that tend to all gravitate around this concept of establishing trust through understanding. And here understanding can mean a few different things. But it's really AI security that we're talking about and not IT security. So value alignment. So with things like the Sorcerer's Apprentice or the Genie's Three Wishes or King Midas, these are actually thousands of year-old stories about asking for something that you think you want, but realizing you didn't really ask for it right. And AI, as essentially pure leverage, will leverage the hell out of what you ask for. And oftentimes you will get these sorts of effects. So it requires more than accuracy of the system, because oftentimes that accuracy is against a proxy that's just easy to set up when you are testing that system. And having something like just rules, like Asimov's rules, is similarly just really proxy for what you want, because it's very easy to find loopholes in pretty much any simple set of rules. In any definition or a set of definitions, there are loopholes you can literally drive a truck through in a couple of years. So highly intelligent agents are able to pursue pretty much any types of end goals. And these are just by themselves just originally independent of what we actually value. So what I mean by this is you can think of it as two different dimensions of capability of doing pretty much anything, and then of like rightness or like makes sense-ness. And these are quite independent. Humans happen to mostly do what kind of makes sense because we are relatively hardwired and trained in being the architectures that we are biologically and growing up the way that we do as people. We get trained in certain ways that make some sense to the sort of human environment that we care about, of playing nice with others and not setting a cat on fire and things like that. So there's actually a pretty broad set of research within value alignment that is unfortunately not as broad as it needs to be. These are different research threads that are related to each other, where research is needed in all of them, much more than is going on today. So, broadly speaking, there are mechanisms for representing ethics, for learning values, for eliciting values, trying to represent various types of ethical theories, looking at new types of game theoretic analyses of different types of actions, and seeing how robust those systems that can be generated through things like mechanism design might be able to be. There's trying to imitate humans, trying to generalize what it is that they're seeing from multiple humans, trying to model the actual operators or model the teachers, trying to figure out if those teachers are actually meaning to teach what exactly it is that they're teaching, or if they're simply encountering some human foible and then the system needs to correct for that and sort of factor that out. Oftentimes these things are the case. When the system is watching your actions and seeing that you just Googled a salad place and you're walking toward that salad place, and then on your way you see a pizza place and you happen to go in there, your Google Now will realize, or a future version of it will realize, you know what, you intended to have some salad, but you smelled the pizza and you went and got the pizza. So maybe it needs to figure out a way to help you take some different route to that salad place that doesn't pass by the pizza place. So figuring out these values and the way that they're expressed and the way that they're elicited or surfaced will actually be pretty important. A contextual awareness of an environment and of whatever it is that the system is trying to understand in the first place can be very important. Without awareness of the broader context, it's very easy to get confused about ambiguities. Oftentimes systems model only a very small portion of the world, even though they may even operate in open world contexts. So they essentially don't really have very much common sense. And so even if you intend the system to operate in some very narrow context, what I'm claiming is it's important to model much more of the world that's surrounding that context. So it can figure out if there is some sort of exception it needs to handle, or some sort of modulation of what it's doing, or trying to mitigate some side effect that would go on in the world for something it would normally do. So typical gaps in abilities from things like this are not really understanding the periphery of what's going on, not learning the causality, and having concepts that are ungrounded. It's pretty important in these sorts of contexts that one understands the theory of why some concept should be considered to be grounded, and how the groundings work in that domain. And learning to learn, and meta-learning and meta-knowledge and metacognition to some degree are all pretty relevant for understanding the context that will include oneself. So of course the average human builds up an enormous amount of implicit knowledge from just being raised as a child in the world. So here again we have some various research threads for mitigating these issues. Apologies that it's kind of small. So things like having much more realistic world models, being able to model common sense or have very comprehensive common sense knowledge bases and reasoning, being able to represent concepts in a way that is parsimonious geometrically, so they can be learned much more fluidly and flexibly, and connected to other things that might not otherwise have been connected to them. Being able to manage uncertainty better and identify it and recognize when the system is encountering an environment that is different than that which it was trained on. So being able to be robust to what we call distributional shift there. Being able to reason about its own resources available to it, and being able to have contextual understanding of both the symbolic and the sub-symbolic processes that are going on inside of itself. Another topic, sometimes called reward hacking or reward gaming or wireheading or computational masturbation. These are all the same thing. It's essentially switching channels of sensory input or modifying itself to provide rewards that are essentially undue. So essentially ungrounded reward signal. So I'll give an example in the next slide. Sometimes this manifests as over-allocating attention to poorly grounded hypotheses, and keep on exploring there, or keep on racking up this unintended reward there. So one example would be a genetic program that's a trading agent that's trying to just increase its fund balance, which the original programmer obviously assumed it would do that by trading. But if it's able to modify its program, then simply incrementing the balance, in its program in a hard-coded way would be a much faster, easier way of getting to what's being measured. That's kind of an obvious gross example, but another one which is slightly more real world, but still, cyber, I guess. So there's this video game, this boat racing game that OpenAI was playing with, and they were doing some deep RL on it, and they were trying to maximize the score of this boat racing. And they found that what the system tends to do is essentially do some cool drifting, like if you've seen like Tokyo Drift, essentially on the water to rack up style points. So it just keeps on literally going in circles, just doing these cool turns. And it never actually finishes the race. So it is a boat racing game, and while there may be, some coolness points for doing some cool stuff while you're racing, I mean, in theory, one kind of assumes that one would finish a race. But the score doesn't really account for that if you're just trying to maximize that score. So that's kind of an example of that. So there are various techniques that people have thought of so far, but it's likely that these are not sufficient for dealing with the issue. Again, for all of these issues I'm talking about here and all of the possible remediations, much more research is needed, both for finding the possible remediations and actually making them more robust. And I'll get to how you might be able to contribute to that a little bit later. So here when we say pursuing environmental goals, so oftentimes proxies are used for determining how well something is approaching its goal. And this is simply modeling that fact. Modeling the fact that you are using a proxy, and maybe you should actually be using multiple proxies, and maybe you should be analyzing the channels through which that proxy can be modified or tampered with, or simply how it might degrade. There's various ways of playing with reward functions, trying to cap them or do pre-training, have multiple rewards, trying to blind to some adversarial examples. But all of these are quite tentative. Generally, the emergent instrumental incentives or subgoals will come about with more general, more powerful systems. These have been pretty rare so far. There certainly have been a handful of examples of these that have been seen in the wild, but very narrow systems like, like Deep Blue or something are not going to come to these because they have absolutely no power over, how many VMs they're using or things like that. But a system that has some sort of meta control and meta reasoning, metacognition, can actually help to regulate these things a little bit better. If it is able to gather resources in some other way, then it may simply do that because of this concept of instrumental subgoals. So this is essentially coming from planning. So if it has some top-level goal, it can figure out that if it has better capabilities, it can achieve that goal better. And so better capabilities are better software, better knowledge of the world, better hardware, making sure it's not shut off, making sure that it is curious enough about the world to do some exploration, to get that better world model, to potentially have better capabilities to achieve that goal. So, who here thinks this sounds like sci-fi? Okay, one person did that, but nobody else raised their hands. That's good. So, one example of this would be a home robot that is trained to, let's say, get you a cup of coffee. So you're sitting in your living room, your robot's sitting next to you in your living room, you tell it, hey, go get me a cup of coffee. It walks across the room, gets you a cup of coffee, brings it back to you, and it did its deed, and it gets a reward signal. Now you introduce a coffee table, and it has to figure out it needs to go around the coffee table to actually do that same thing. It may originally bump into the coffee table and then learn it can't, just walk against the coffee table or something like that. And then, eventually it walks around the coffee table, it gets you the cup of coffee and comes back. Now, what happens if you ask it to get you the cup of coffee, and then as it's walking to the coffee machine, you press its off button. You walk over to it and you press its off button. Well, if it's recording everything and, learning from all of its, everything happening to it and everything it's doing, it's going to learn that when its off button is pushed by somebody, that it cannot achieve its goal. It cannot get that reward signal. So next time, when you try to press that off button, it can take its hand and block you from pressing that off button. And this is something that I think probably the vast majority, this is just from my, speaking with many AI researchers. They know that this is quite plausible and possible when they hear it, but they never really thought of this in the first place. And this seems like one of the important sorts of things that click in them. This is not pure sci-fi that's being raised. So Google actually wrote a paper about this, I believe, last year. And they came up with a sort of a tentative solution, which was essentially trying to have the learner ignore or to excise from its memory that information about you pressing the button. But that's not foolproof, and it's likely there was some more research needed on, fixing this sort of issue. So generally, we can look at things like measuring the impact of a given type of behavior, potentially structuring in some regularizers in the learning algorithms, trying to do various kinds of safe exploration, potentially simulating exploration or having oversight or bounding the exploration to sort of known safe parameters, which are sort of iteratively learned and updated. There's a concept of computational humility, which is essentially having uncertainty and discounting and awareness of the agent's own fallibility. And also mild optimization, which is essentially not over-optimizing for whatever it is that you are optimizing for in the first place. Because this concept of optimization has actually been, on a practical level, pretty poorly understood. Systems are finite, and that's why they don't do crazy over-optimization these days. If you simply have a system optimizing for something, it's going to use its resources to do that. But if it has the power to gather more resources, it can do a better job at optimizing. And oftentimes, you're not going to be getting to the ultimate, 100% of whatever it is you're optimizing. There could always be this little incremental amount. You might be reaching asymptotically or something. And oftentimes, or I should say, it's quite plausible that a system that is not otherwise regulated could be gathering more and more resources to just get this tiniest incremental improvement. And this is something you definitely want to avert via things like what we might call quantization or satisfaction, or satisficing the goal rather than optimizing for it. Just getting close to whatever it is that we're trying to get to, and just having some tolerance that's sufficient. And also another sort of more relatively undervalued and probably generally quite applicable approach is multi-objective optimization, where there are different types of objectives that are being considered in a bag, if you will, which You can throw more objectives in that bag and remove objectives from that bag. And there's this Pareto frontier that you are ideally constantly approaching when doing this optimization. So the benefit of this over simply having a single objective function is that you can move around to different points along that Pareto frontier and potentially find new kinds of synergies between these functions that are not necessarily going to come about when you have your fixed weights on them and your linear combinations that are hand created. So control and control degradation and issues. So these default instrumental incentives can make advanced AI modify its control channels. It can try to, as I say, block your hand. So how to maintain meaningful control? It should want to defer to humans when it's unsure of something important. You should have it allow authorized humans to stop it, modify it, interrogate it, or destroy it. I will skip the details of this example, but basically a system can block an expected control flow, such as an observation channel, if it determines in its planning and optimization that restricting that can improve its outcome per the reward signals it gets. And if you have assumed that control channel will stay in place as some sort of safety mechanism, then you should just be aware that that's not always the case. So, oversight breaks into things like monitoring, so having causal accounting, having transparency, visualizing situational awareness, audit trails, but also things like transparency of white boxes, interpretability of black boxes. So this concept of being able to understand what's going on in the system. And this applies to both the creator of the AI as well as the operator. And the operator might very well be a layman. This is also a little bit related to other regulation that the EU has passed on interpretability for important decisions. They're actually requiring that sort of material decisions be explainable, which is probably a good thing overall, but I mean the specifics of it and the implementation are kind of tricky. Having scalable oversight where the system is only asking for what it absolutely needs and making sure that the system is structured in a way, potentially hierarchically, where what is really important from the person training it or the people training it are being extracted. So potentially not really even the thing that it's learning directly, but maybe generators of that thing, or maybe values. So again, this is kind of an open research area. And what I mentioned before of computational humility is also related to computational deference. So being able to have having the system want to defer to the human operator. So in the foundations of agency, we encounter questions like, how do we enumerate the actions we can actually take or have taken? So essentially formalizing counterfactuals, formalizing the evaluation of all the possibilities we might actually want to take. Excuse me. There's actually very little theory on this so far, and it's a relatively new field, but there is some being started these days. How can we make decisions consistent, maintaining stable goals, despite learning new paradigms? So ontologies might change. They might be refactored. They might shift. They might be combined or whatnot. Or the system itself might also be modified. it might modify itself. So how can we decide to do something in a way that's actually stable and sort of provably stable or sufficiently provably stable over time? And how can we model successor programs, superior programs, given that they will be superior and we can't just simply have an instance and try to see what happens? So there's a lot of important research that's going on here, or I should say there's some important research. The Machine Intelligence Research Institute has certainly been leading the way on these issues here. And I encourage you to Google them, MIRI, M-I-R-I. Verification is another important topic. This is going to the fact that human code is very haphazard. There's lots of bugs in it, and we need verification to make sure there aren't simply implementation bugs. So again, validation is correctness going from ideas to specification. Verification is going from specification to implementation and making sure the correctness is there. So running a little bit short on time, so I'll be skipping some of these things. With security, there are new classes of adversarial testing and training, tainting of training data. Issues in statistical-behavioral trust establishment, where we actually want to make sure that an entity being learned from is trustworthy. So I'm talking about a different example than what's showing on the screen right now. So the chatbot Tay, you may remember from Microsoft a couple of years ago, was learning from people on Twitter, and it learned overnight to be a misogynist Nazi. And in theory, if it had this concept of value alignment, and if it had this concept of statistical behavioral trust establishment, it would be able to determine which people on Twitter to learn from and which people not to learn from. And so it would have become kind of closer to what Microsoft intended of, like, simulating an average, teenage girl or whatever it is. In the long term, when we look decades, centuries, millennia out into the future, since we will have this ultra-powerful AI, how do we want society to be structured? My boss at FLI, the founder of it, Max Tegmark, wrote a book that came out a few weeks ago, which is a New York Times bestseller, on this very topic, looking essentially billions of years into the future, and how we might want that to play out given AI. So I highly encourage you to get this book. And he is actually speaking in San Francisco tomorrow at this event over there, this Eventbrite link. So you may want to take a picture or something and go to that. I also encourage you to go to this website, AI Aftermath Scenarios, and potentially read what these different scenarios are about, and you can vote on them. And this graph is coming from people who voted, who presumably, hopefully read the book, but there's sort of a cheat sheet about what these scenarios are about as well. So we want to do a lot more of this kind of research. So we had one grant round that I mentioned of those 37 teams. We want to do a second grant round very soon. So there's $3 million from Musk that will be seeding this, but we really want more stakeholders involved. We really want more high net worth individuals and companies and foundations and organizations of all kinds to get involved and to fund some of this. We also want to be much more inclusive of other parts of the world, especially Asia, given that in the first round we had very little representation from there, or essentially no teams based in Asia. But we have been engaging more with Chinese academia and large companies and a little bit of government. So we are hoping for some engagement there. But certainly if you know any high net worth individuals who care about this topic, please let them know about this. So please go to futureoflife.org/AI activities for more. And you can email me at this email address. And thank you. So that's an excellent question. So Max Tegmark has actually also written on different ways that one might want to test for consciousness, which evolve a little bit from Giulio Tononi's concept of integrated information theory. Now, Tononi claims, and I can't go into all the details here, it's a little bit involved, but please feel free to Google that. So Max has a paper out, Consciousness as a State of Matter, and Tononi has a book out called Psi, just PSI, or C, maybe it's called. Yeah, there is this concept of maybe there is actually a way to measure for a system that is expected to be conscious, just how conscious is it at a given point in time. Which is not the full answer to what is consciousness, but is starting to go in the right direction. Yes. So the question is, what do I see as the future of opaque versus interpretable AI? So I'd like to go to the slide I had on interpretability. So monitoring here. So yeah, I think it's going to be very important in the future as decisions become much more complex. Doctors and people in finance and generally people who want to be able to trust a system's decisions really want some sort of explanation for why it came to that decision. Not because they distrust the system per se, but they just want to have some understanding of what the system is saying and why. And they want to have some part in determining the confidence in that. And they want to have some part in just understanding the situational awareness of it. So there are more and more techniques for things like analyzing the dynamics as a deep net learns and trying to have some amount of kind of almost sub-symbolic but semantic tagging and flow diagrams of what is being learned, when, why, and what the relationships are between things. So there's some amount of taking what might otherwise be black boxes and bring them a little bit more into white boxes. There are of course many other types of machine learning methodologies or techniques. Some of them are much more amenable to interpretability. Something as simple as like a decision tree or something is obviously much more interpretable than a neural network. But there are dozens or hundreds of different such techniques. And it could be that sometimes one of those might be really what's called for, even if technically the accuracy is a little bit lower. If it is more interpretable, then that might just be better overall for the system. And there's a lot of research going on in making systems more interpretable. Even for totally black box systems, you can still pump data through it of various kinds and get some sort of gradient of what it's doing and potentially, why. Being able to visualize and explain a situation is going to be more important for lay end users, and I think that we're going to be seeing a lot more of that. There are techniques for simultaneously learning the explanation for something along with the actual answer, and those are pretty exciting approaches. So hopefully those might just be more in line with a variety of different learning techniques. Yes, so we are a nonprofit organization that is trying to simply save the world. So we encourage people to steal these ideas.
So patenting
Yeah, I mean, I guess in theory we could defensively patent things and just open them, which maybe we should be doing. That's a good point. Like Tesla, opened a lot of its patents or all of its patents to let everybody use them, but it still wanted to patent them in the first place. So to have that control, to be able to so somebody else wouldn't just be able to take them.
it might attract more people to invest maybe.
Yeah. So the grant round I'm talking about here is a type of investment. But it is not an investment that is seeking money back. It's an investment that is seeking more safety and ethics going into these systems for the future and making the world safer and better and more beneficial to humanity.
What's next?
Yeah, good question. So I think it's an important. I'm sorry. The question is. How much will interpretability of what might otherwise be black box systems be able to help the overall safety of AI overall? So I think it's a very important capability that if we didn't have that, then it would be very difficult to say much of anything about what's actually going on. So once we have that, we can start to sort of bootstrap from those low-level understandings to higher-level understandings of essentially the types of dynamics that are going on in the learning. So what sorts of things are most important for that system to be learning next? And what sorts of phase changes are happening inside that system? So I mean, partially, to some small degree, right? Because it improves the interpretability, which humans can then use in theory for providing corrections to the system, for understanding where its blind spots would be, for understanding if it's interpreting things incorrectly. And then, in theory, there can be something similar to active learning going on, or like just human oversight of just curation of its outputs and curation of the network potentially. Yeah, excellent point. Yeah, so a lot of these types of dynamics, are specific to not AI but to intelligence, and dogs have intelligence and humans have intelligence, organizations have intelligence and countries have intelligence, and so really it's good to think about these things a bit more metaphorically than just at the purely technical level. So, hence my little gray, descriptions of these 8 areas here. It's really about how should intelligence be structured and how should intelligence be utilized and how should intelligence be influenced in order to get the types of learning, the types of behavior that we want. And there are many, many different psychological analogs to a lot of the lower level things I'm talking about as well. And so I'm happy to connect with anybody about those in more detail. Well, I'm not sure what you mean by this security being internal security. So we're...
Repeat the question.
Oh, I'm sorry. So the question is, security is very important. The electric grid gets hacked many times a day. And how do we think about security?
And so the computer people, the IT people right now have systems whereby they work very hard to realize that they're being hacked and to get around it. It's a whole field in itself. And how does that fit in here?
Sure.
Are we going to end up having to train these
so there's AI for security, and then there's security for AI, and you know, they're very related. So AI for security would be something like you were mentioning of essentially intrusion detection and being able to model what normal behavior is and anomalies and being able to model bad actors potentially. So certainly that can be rolled into this as well.
So is it any deeper with the deepness here? Is it going to be any harder, I guess, is what
Yeah, so I think it can be. Certainly IT security, you know, is quite relevant, and it's kind of assumed in a way as an underlying base here. I mean, not assumed in the way that we actually expect it to just be automatic, but rather, you know, IT security is important for any sort of software, any sort of system. And, you know, there are many different ways that like IT breaches can interact with a lot of these other types of things. So we look at like misuse risk and, you know, being able to, you know, we are also looking at using AI to support security here, and especially making sure that the more important parts of the system are protected, you know, much more strongly than the less important parts. So things like verified software all throughout the stack can help with this. Things like security validated software engineering practices. But really, part of the point of this slide is that a lot of the security issues that come up are not traditional IT security issues, because the system is operating at a different kind of plane, essentially. So the question is, how important is it for engineers to be educated about ethics and potentially other parts of philosophy? You know, I think it actually is quite important. I think engineering ethics could be a little more specific than you know, overall ethics, and it's not necessarily that one needs to learn the history of philosophy and of ethics to learn some of the basics. One endeavor I'd like to draw your attention to, sort of in answer to this, comes from the IEEE. So there's this document called Ethically Aligned Design, which is already out in its first version. The second version is close to publication as well. And this is sort of a little bit of a living iterative document where different design issues in AI and how those interact with ethics are addressed. So there's about 500 people who've come together and essentially written a book here under the auspices of the IEEE about various types of issues and possible ways of addressing those in this intersection between AI and ethics.
So